For problem number 12 from the homework. So you have those strings. This is 50, this is more slanted because it's 30, and this is the lamp, and has a weight of 200 newtons. So this is your Fg, which is 200 newtons. Now here you have a T3, and then you have a T1 and T2. The problem asks for tension in every single one of those tensions. So for this one, so this is a T3. So for this portion of your problem, okay, you have T3, considering the free body diagram, you only have T3 minus Fg equal to 0 because the lamp post is now moving. The lamp is now moving, is just suspended. So T3 is equal to Fg, which is equal to 200 newtons. So for T3 there are no problems. Then consider this point here, this node. In this node what happens is basically it's just like, because this is 200, it's just like the 200s are hanging here, okay, and those two strings have to hold the 200 newtons. So if this is the y component, the y-axis, this is your 50 degrees, this is your 30 degrees, then in this case what's going to happen is that you have this component of T1 and this component of T2 added together to give you this T1 plus T2. So basically T1 sine 30 in this direction here, plus T2 sine 50. So together those two components are the ones responsible to hold the 200 newtons, right? So at this point you have this equation, but you have two variables. So where do you find the second equation in order for you to solve for those variables? Well, horizontally, which is here, horizontally you have this tension here and this tension here, that they do equilibrate each other. So this is for y. For x, you have equilibrium between T1 cosine 30. This one has to be equal to T2 cosine 50. At this point, just you can solve, because you can do, for example, from here, T1 equal to T2 cosine 50 over cosine 30, right? So this is now an expression for T1, which you can substitute in the first equation. So instead of T1 here, you will write T2 cosine 50 over cosine 30. So this is T1 times sine 30 plus T2 sine 50 equal to 200. So at this point, factor out T2. So T2 times cosine 50 sine 30 cosine 30 plus sine 50 equal to 200. Therefore T2 is equal to 200 divided by the parenthesis, which means 200 divided by parenthesis, this whole thing. So 50 cosine times 30 sine divided by 30 cosine plus 50 sine, close parenthesis, being 170, let's say 6 newtons. So that would be your T2. At this point, how much is T1? Well, because of this expression here, T1 is equal to 176 times cosine 50 over cosine 30, which is the same as, so this one times 50 cosine divided by 30 cosine, so 131 if we round. Okay, so that will be for problem number 12. For problem number 13 instead, that. Okay, so you have a piñata hangs from the three cables. So this is 13. So you have a wall here, string, and the piñata is hanging here. Okay, and you have a T2, which is pulling up the piñata that actually has a weight. Then you have this T3, which is equal to 39.2 newtons, and you know that this angle is 37. Now this force here, right, is like that, so it's made of this force and this force here. Okay, so this means that T3y, so along y, how many forces I have? I have this one, which is T3 sine 37. Then I have this one, because I can imagine the block is hanging here. So I also have minus mg, and there's no motion, so this is equal to 0. And along x, instead, what I got? I have this force here that is holding in this direction. This one is holding in this direction, and also those two are in equilibrium. So I have a T, this is T1. T1 has to be equal to T3 cosine 37. Okay, so at this point T1 is equal to 39.2 cosine 37, which is a number. 39.2 times 37 cosine equal to 31.3 newtons. So this is T1. T2 is equal to mg, this one. From here I also find that T3, which is 39.2 sine 37, is equal to mg, right? So this means that T2 is equal to, from here, T2 has to be equal to mg, which is also equal to 39.2 sine 37, which is 39.2 times 37 sine 23.6 newtons, but this is mg, m 9.8. So from here, mass is equal to 23.6 over 9.8, which is 2.4 kilograms. And we solved everything. Then the other, so number 14, you have the man standing in the elevator, so that's the elevator, that's the man standing there, has a mass of 80 kilograms times 9.8 meters per second squared, gives me the weight of the man. So 80 times 9.8 is equal to 784 newton, right? Here you have the normal force of the floor. Okay, the elevator is constant velocity, so F net is 0. So in this case, Fn is equal to 784 newtons. Then the part, so this is part A. Part B, instead, elevator now slows down to reach destination, so it's moving up and slowing down. So now instead you have still the elevator, you have the man, same weight as before, Fg equal to 784 newton. You have Fn, but what is changing is that the F net is negative, because it has a negative acceleration, is equal to 80 times negative 0.5. Okay, so this means that this is that's 40 actually. So this is equal to 40 newton. Negative, usually, you know, I don't like to put it there because I have the arrow, but whatever. So at this point I know that F normal minus Fg equal to minus F net. So F normal is equal to Fg minus F net. So this is equal to 784 minus 40. So this is 744 Newton. And then the last part of the problem instead is moving. Oh no, it is not moving. So you have a rocket, number 15, a rocket fired upward. So that's the rocket. And you have acceleration, so this is the F net, which is m times the 32 meters per second squared. The mass of this is 200 kilograms. Experiences air resistance. This is going upward, so the air resistance is down. Force of friction. You also have force due to gravity, and you have the thrust, which is the applied, which is up. Now this force of resistance here is 12,000 Newton. This is 200, which is the mass, times 9.8. So they want to know what is the thrust. So Fa minus force due to gravity minus Fg equal to plus m32. Okay, so Fa, which is the thrust, is equal to force of friction plus gravity plus m32, which makes sense actually, that to be fired up, you have to win every single one of those forces. So this is 12,000 plus this is 209.8 plus this is 232. So the thrust is equal to 12,000 plus 200 times 9.8 plus 200 times 32. So this is 20,360 Newton. And you're done with those.